Why does freezing lead to a solid state? Imagine a busy crowd at a concert suddenly freezing in place. What causes this sudden stop? In the world of science, it's all about how molecules behave when temperatures drop. When a liquid cools below its freezing point, something interesting happens. The molecules lose energy and slow down. This slowdown makes them stick closer together because the forces pulling them apart weaken. As they get closer, they start to arrange themselves in a specific pattern called a crystal lattice. This pattern is what makes a solid, with molecules locked into a fixed position. In liquids, molecules are close but still move freely past each other. They're held together by intermolecular forces, which are like tiny invisible springs. When the temperature drops, the molecules lose what's called kinetic energy, the energy of motion. With less kinetic energy, the molecules can't overcome the attractive forces pulling them together. This causes them to cluster into tiny groups called nuclei. These nuclei act as seeds, and more molecules join in, building a structured, repeating pattern. This process is called crystallization. As the molecules settle into this ordered structure, energy is released into the surroundings. This energy releases is known as the latent heat of fusion. Because of this, the temperature stays nearly the same during the phase change from liquid to solid until all the liquid has turned into a solid. From a thermodynamic point of view, freezing is a first-order phase transition. This means the system moves from a higher energy liquid state to a lower energy solid state. The key factor is the balance between the molecules, kinetic energy, and the attractive forces between them. When cooling reduces the kinetic energy enough, the forces dominate, and the molecules lock into a solid. Think about water turning into ice in your freezer or snow forming in the atmosphere. These are everyday examples of freezing. Understanding this process is important in many fields like meteorology, food preservation, and even materials science. It helps us control how substances change states, which can affect safety, quality, and performance. So, in simple terms, freezing leads to a solid because cooling slows down molecules, allowing the forces between them to organize the molecules into a stable, fixed structure. This microscopic change creates the solid state we see and use every day.